Hello and welcome, my gentle and of course very modern apes. My name is Erica, this is gutsickgibbon, and what we do here is we look at topics of biological anthropology, so things like primatology and human evolution. Sometimes we stray into other areas as well, and occasionally we look at these topics under the lens of debunking pseudoscience. But that's not what we're doing today. Today we're talking about a new, cool discovery coming out of Anatolia, Turkey. So for those of you who don't know, I am a PhD student in biological anthropology. I'm starting my third year here now in the fall, and what I study specifically is a period of time called the Miocene, from about 20 million years ago to approximately 5 million years ago. And on the early end, this encompasses the origin of the apes, and on the latter end, so coming closer to the present, this encompasses the origin of the hominins. So the line of critters after the split, after our ancestors split with the chimpanzee's ancestor. So our common ancestor is this little node here, and then right around 7 million years ago, these two lineages split. Chimpanzees, the panins, go one direction, and humans, the hominins, go another. So I should specify here, hominins aren't just the direct lineage leading up to modern day humans, but also include all of the apes that are more closely related to humans than they are to any other living great ape, which means we have a lot of animals within that time period after the split, so from roughly 7 million years ago to present, that you wouldn't have, if you met them in person, suspected are more closely related to humans, but they would have been nevertheless genetically, and their morphology gives us many clues to that relationship. So these are things like Ardipithecus, the members of genus Paranthropus, different members of our own genus Homo, that didn't terminate in Homo sapiens, so things like Neanderthals, Denisovans, Homo naledi, Homo floresiensis. The family tree is very crowded, and we, as a very narcissistic species, tend to assess it by different members' relationships to us specifically because, well, we're the last ones, and we're the only ones presently investigating our own lineage. Now, 7 million years of evolution is a long time, and it's generally accepted on the basis of genetics that the vast majority of this evolution occurred on the African continent, specifically, most likely, in East Africa, around the areas of Ethiopia, Kenya, and Tanzania. It isn't until around 2 million years ago, at least with present evidence, that hominins start to leave Africa in these bursts of activity, bursts of migration, expanding outwards into places like Eurasia, so Europe and Asia, and eventually evolving into populations that are specific to these locations, like Neanderthals, Denisovans, or Homo floresiensis. But Homo sapiens evolves still in the heart of Africa. Again, this is robustly supported by several lines of genetic evidence. So the taxonomic ranks of humans and our close relatives gets a little confusing after hominoids, so I'm going to review it with you really quick because we're going to be talking about some serious implications for the origins of one of these groups today and where that might have happened. So hominoids, this is the superfamily, right? So you've probably heard that we're hominids, but we're also hominoids. So hominoidea is all of the apes. That's humans, that's gorillas, that's chimps, bonobos, orangutans, and of course, the gibbons. These two groups split into our respective families, Hominidae for the great apes, including humans, of course. So the gibbons are booted from the group here into their own family, Hylobatidae. Things get more specific after that. The Homininae members and the Ponginae members, so this is the orangutans being booted here, and the rest are the hominines. So hominines are going to be the group we're going to be discussing today. That's the African apes, the apes with an African origin. Rather, I guess I should say the great apes with an African origin. So humans, chimpanzees and bonobos, the panins, and gorillans, so members of gorilla. The split gets more specific after this. This is going to be gorillinae for gorillas and homininae for chimpanzees, bonobos, and humans, so that's another specific split there into respective tribes. And then lastly, we have the split into the subtribes, so Panina and Hominina. So these are the panins and the hominins. The split 7 million years ago is this little node right here. This is going to be about 10 million years ago for the tribes, the gorilla tribe and the human and chimp tribe. And then the Pongins versus the members of Homininae. I guess I should say the members of Ponginae versus the members of Homininae here. And then up here we have the Hylobatids versus the hominids, and hominoids are all the way back here. So the Miocene, the period of time that I study, spans the origin of the hominoid. So this little node, the sort of origin node all the way back here, and it ends right in the middle of sort of the hominin origin here. So the period of the Miocene is like the real planet of the apes. We are finding apes all over the place. We find them in Africa, we find them in Europe, and we find them in Asia, and they are pervasive in all of those locations. Now, the origin of the members of Pangea, so what would become the orangutans, like where that happened is not controversial. Pretty much everybody agrees that there's an Asian origin for orangutans and their kin. So like Gigantopithecus, Shivapithecus, Encaropithecus, Lufungpithecus. No real controversies there. The question is, where do the hominines find their origin? The African apes, the ancestor of all gorillas, all pannin, so chimps and bonobos, and humans and our kin, our relatives in the fossil record. Where do they first show up? Some have proposed that the first hominines show up in Europe and radiate downwards, while others have proposed that the first hominines show up in Africa and radiate upwards, and then also some just stay in Africa, where eventually they yield the lineages of modern-day gorillas, modern-day pannins, and modern-day humans. Luckily, a brand new Miocene ape has just been discovered, and it might just solve the problem. Or it might make things more complicated. We'll see. A new open access paper titled A New Ape from Turkey and the Radiation of Late Miocene Hominines by Sevim Erol et al., David Begun is also an author on the paper, has just come out a few days ago, and I think it's really exciting, so I thought we could perhaps go through some of this together. We will start, as we always do, with the abstract. Fossil apes from the eastern Mediterranean are central to the debate on African ape and human, so the hominine origins. Current research places them as either hominines, as hominins, so humans and our fossil relatives, or as stem hominids, no more closely related to hominines than to pangans, the orangutans and their fossil relatives. Here we show, based on our analysis of a newly identified genus, Anadoluvius, from 8.7 million year ago site of Cora Kyrler, I'm going to say it like that, Cora Kyrler, in central Anatolia, that fossil Mediterranean apes are diverse and are a part of the first known radiation of the early members of the hominines. The members of this radiation are currently only identified in Europe and Anatolia. Generally accepted hominins are only found in Africa from the late Miocene until the Pleistocene. Hominines may have originated in Eurasia during the late Miocene, or they may have dispersed into Eurasia from an unknown African ancestor. The diversity of hominines in Eurasia suggests an in situ origin, but does not exclude a dispersal hypothesis. So what these guys are saying is that they have found a brand new fossil ape, newly dubbed Anadoluvius, found in Turkey at a site that is approximately 8.7 million years old, and that this new ape sort of unites a group of other Mediterranean apes, so Anadoluvius, and they're going to say later, including Gracopithecus and Oranophithecus, and that Anadoluvius unites these sort of three genera of apes into the origin group, or at least something very close to the origin group of the hominines. And what that suggests to the authors, since this is a Mediterranean site, is that the actual origin of the hominines is probably going to be in Europe. But they do specifically state here that this does not exclude a dispersal hypothesis. It just adds a little extra support to a Eurasian origin, weirdly enough, of the African apes. On the face of it, what this would mean, if true, is that some member of this original sort of hominine group manages to disperse downward into Africa, where it eventually yields the lineages that become modern-day gorillas, modern-day pannins, and modern-day humans. So let's learn a little bit more about our new friend Anadoluvius. We're going to read a little of the introduction here because I think it does a good, concise job of summarizing what the current debate is. The origin of the hominines, so the African apes, is among the most hotly debated topics in paleoanthropology. The traditional view, ever since Darwin, holds that the hominines originate in Africa, where the earliest hominins are found and where all extant non-human hominines live. More recently, a European origin has been proposed based off of the phylogenetic analysis of late Miocene apes from Europe and central Anatolia. The fossils described here attest to a lengthy history of hominines in Europe, with multiple taxa in the eastern Mediterranean known for at least 2.3 million years. Our phylogenetic analysis, based off of the new specimens described here and a large sample of other fossil and extant hominoids, so supplementary notes here, supports previous research confirming the hominine status of the eastern Mediterranean apes. Our most parsimonious phylogenetic results suggest that hominines in the eastern Mediterranean evolved from the Dryopithecines in Central and Western Europe, though there are alternative interpretations. Either way, the oldest known hominines are European. They may have dispersed into Europe from ancestors in Africa, only to become extinct. However, the more likely and more parsimonious interpretation is that hominines evolved over a lengthy period in Europe and dispersed into Africa before 7 million years ago. So here is Anadoluvius, the uniter of the hominines, evidently. It's a fantastic find. It's a partial cranium, as said down here. It's designated as female, but not to the canines, as we'll find out in a minute, which is fascinating to me because, as you guys know, I study specifically within the Miocene the canine teeth of these apes. It's a really great looking fossil. It's got basically the whole face, portions of the neurocranium here, some excellent preservation on the dental arcade. We've got molars, premolars, canine, and incisors, a representation of all of the teeth, and it's pretty sweet. That beautiful partial cranium, though, isn't actually the holotype. So the holotype is a partial palate, a largely complete palate, I guess, as they've described it here, but I guess not a full palate. Fragmented but largely complete male palate called CO205, and it has also a lot of the dental arcade. It has the lateral incisor to the third molar and the right canine to the second molar, and it's a palate, so these are all maxillary or upper dentition. This is all upper dentition. Paratypes, on the other hand, are other fossil finds that are used in the original description, and this is the original description. And they're basically used to corroborate the designated characteristics found in the holotype. So these ones are going to be CO300, a male mandibular fragment, a male mandibular fragment, a female mandibular fragment, a female partial cranium. That's our nice one up there. And a handful of others, I believe, probably some teeth, I would imagine, in here as well. So they describe the cranium here first, and that's going to be that nice female one that we just looked at. They describe some of the characteristics of its preservation and how it was initially interpreted. And then we have this really, really cool figure here that I like a lot and I want to go over with you guys, just checking that you guys can see it. So this is a comparison of palate, so it's a cross-section of the palate, so it's cut down the middle. Ikembo is over here. This is one of the first, foreshore apes, hominoids, in the fossil record. Ikembo is found typically on Rusinga Island. It's actually quite near where I did my fieldwork. I went to the site where the first Ikembo was found, or the first, we'll say first asterisk. Rudopithecus is here below, and Rudopithecus is actually being represented here with two specimens of what were previously described as Dryopithecus branchoi, which is interesting because, as you can see, there's some serious canine dimorphism going on here. That's not typically how I understand the dimorphism of Rudopithecus, but we'll come back to that when we come back to it. Below is Anadoluvius, and we have the female palate here on the left and the male palate here on the right. The canine of the female palate is pretty worn, honestly, but fascinatingly enough, in its unworn state, it doesn't look like it's going to be that much smaller than the male canine, which for this period of time for apes is pretty unique indeed, especially considering, looking at these two palates, the size dimorphism that seems to be going on here. The male palate is pretty substantially larger than the female palate here, and yet the canines, on a projection at least that I can see, are about the same height, which is pretty rare, again, for apes in general, but it's also strange considering that this is an animal that appears to be size dimorphic and canine monomorphic, which is fascinating because that is exactly what we'll see later on in Australopithecus, but not Ardipithecus, which is jammed temporally between these two. So it seems like once canine dimorphism goes away, and I've said this before on this channel, once canine dimorphism goes away, it doesn't come back, at least not easily. But size dimorphism seems like it's a lot more fluid. Like, size dimorphism can come and go. depending on the circumstances of the population in question. So not only does Anadoluvius seem to have a reduction in canine size in both sexes, but so do the other hominines that are assessed here. Like Auranopithecus's canine here is pretty stubby, especially compared to the Rudopithecus males up here, which have these pretty tall, impressive canine teeth. The same is true for Hispanopithecus, which is less dimorphic by quite a bit as compared to Rudopithecus, at least as I understand it. It's more on the level of chimpanzees, which are kind of dimorphic in their canines, but not extremely so, like roughly 20 to 30%, 40% at the greatest. So Pongo over here, this is modern orangutan, so they've got enormous canine teeth. Gorillas have big canine teeth. Panins have kind of big canine teeth. They're not anything to write home about compared to the other hominids here in this line over here on the far right, but they're still pretty impressive, especially compared to humans, and especially compared to Anadoluvius, which on the basis of these pictures up here, and they'll say this later on in the text, their canine teeth are smaller than Ardipithecus, a definitive hominin. So that is really weird. And then Australopithecus obviously has pretty small canine teeth as well. In fact, Australopithecus is linked as the one, in this paper at least, with the most similar canine teeth to Anadoluvius. So this is a very interesting question, right? Because Ardipithecus is, especially on the basis of like the morphology seen in its postcrania and in the foramen magnum as well, and some of the facial and dental characteristics. Like it's definitely a hominin, but something weird is going on with the relationship between all of these guys, at least with regard to the canine teeth, which is the thing that I care about. And they actually spend an interesting amount of time on the canine teeth, which I really appreciated. They do some PCAs with, that's a principal component analysis, with the mandible as well as with the cranium, so looking at the maxilla, and I believe some of the teeth as well. So they look at the enamel thickness and compare that to the other sort of groups that the other members of the group, rather, that Anadoluvius is in. So a comparison with Anadoluvius and Auranopithecus is looked at here. So figure 3 shows the root and root canal morphology of CO300, the male mandible of Anadoluvius. Unlike Auranopithecus, the distal roots of the P3 to the M1 in Anadoluvius and Gregopithecus are single fused roots with 2 root canals, so it's got some really weird morphology in some of its teeth as compared to the other members of its group, which isn't, like, root morphology isn't necessarily super constrained, so that's not necessarily out of the question, but I want to read the canine stuff because while it is interesting with regard to what I study, it's also interesting with regard to hominin evolution, because as I said earlier, one of the first things that happens in the hominins is a reduction of the canine teeth. The results of an ANOVA examining lower canine relative size is presented in Supplementary Table 7. In canine size relative to the geometric mean, Auranopithecus is significantly different from extant African apes in having relatively small canines. So, like, let's say hypothetically here that Auranopithecus, Anadoluvius, and Gregopithecus are sort of this ancestral group of hominines that is the ancestor, one of which is the ancestor of all modern African apes. So gorillas, again, chimps and bonobos, and humans. What this would mean is that the ancestral condition of canine size in modern African apes is actually most similar to the human condition in being reduced as compared to what came before, and that modern African apes have secondarily experienced an increase in their relative canine size, which, that's really interesting. The relative size of CO305 mandibular canine, 0.53, is equal to the mean of Auranopithecus males and at the low end of the range of variation for pan males and females. Canines are small in the Balkan and Anatolian sample compared with other fossil and extant apes, including Ardipithecus, being more consistent with the ranges in Australopithecus. So that is really cool. Ardipithecus, a hominin, has bigger canine teeth than these guys here, which is very strange. In fact, I went to the supplementary material just to see it for myself because that seemed like such an insane claim. But I guess part of the reason why I tend to think of Ardipithecus as having small canines is because the specimen that we tend to think of is that partial skeleton, and that partial skeleton actually has some of the smallest canines within Ardipithecus. So I guess the canines can get pretty big, which is neat, again, because it's a hominin. And like, I guess if this group of Anadoluvius, Gregopithecus, and Auranopithecus is like the ancestral hominin condition, then maybe a reduction in canine tooth size isn't even a hominin trait, which would be really weird. And it would cause us to have to reassess some of the hominids that we consider hominins on the basis of their small canine tooth size. Where do they actually lie if a reduction in canine tooth size isn't actually a hominin characteristic, but rather just a continuation of the hominine ancestral condition, and that again, gorillas, bonobos, and chimps have secondarily increased their canine tooth size. It would also suggest that canine tooth size in general, although not necessarily the dimorphism aspect, but in general, like, the canine tooth size is maybe a little bit more plastic than we thought. So really weird stuff coming out of the canines from Anadoluvius and evidently these early hominines. So they do a nice character matrix. They have a nice character matrix that can be found in the supplementary material, and this is used to come up with some cladograms, right? So these are the top 4 consensus cladograms here, the strict consensus cladograms. There's a lot of details included before the conclusion if you really want to sink your teeth into it, but I was hoping this was going to be kind of like here's a summary of a cool new finding video, and it's probably already over 20 minutes long, so short by my standards, but still. Eastern Mediterranean apes previously assigned to Auranopithecus span at least 2.4 million years, with a geographic range roughly equal to the area between Hispanopithecus in Spain and Rudopithecus in Hungary. In the Eastern Mediterranean, as in Western and Central Europe, multiple genera are present. A preliminary analysis of stable isotopes from single-tooth samples of Auranopithecus from RPI and Anadoluvius, as well as larger samples of Hipparionins, suggest cooler, drier conditions in this given location where Anadoluvius is found, and a reliance on C3 plants for both ape taxa. They have thick enamel, robust jaws, and in the younger samples from Nikiti 1, as well as where Anadoluvius was found, and Pyrgos vasilensis, evidence of canine reduction, which recalls the earliest African hominins. So the characteristics that unite them, one of which being a reduction in canine teeth, appears to be like potentially a precursor to the African hominins. Potentially. Big asterisk there. A clarification on the significance of the similarities between the Balkan and Anatolian samples and the late Miocene African hominins will have to await further discoveries. They say Eastern Mediterranean hominins may represent a terminal radiation arising from one or more older hominines in Europe, analogous to the radiation of Paranthropus, presumably from an Australopithecus-like ancestor. Alternatively, given that the European hominines most closely resemble gorillas, it is possible that this represents a radiation of early members of the gorilla clade, mirroring the Middle and Late Miocene radiation of Pongins in Asia. It is also possible that European hominids represent terminal lineages of successive dispersals of hominids from Africa, although there is no evidence for multiple lineages of hominids between 13 and 10 million years ago in Africa, and this hypothesis is not supported by the results of phylogenetic analysis presented here. Finally, some researchers have focused attention on the differences among Eastern Mediterranean apes, suggesting that multiple lineages are present, including the earliest known hominins. In this context, it is worth noting that Greco-Pithecus was only included in the phylogenetic analysis within all taxa, which yielded a poorly resolved cladogram. Greco-Pithecus is grouped with the hominids, but not specifically with other Eastern Mediterranean hominines. However, multiple analyses have concluded that Greco-Pithecus and Auranopithecus are closely related, even if this has not been demonstrated with a formal cladistic analysis. A comprehensive phylogenetic analysis is underway to test these competing hypotheses. Whatever the outcome, the sample of ape fossils from this location, which again I'm not going to try to pronounce, but it's where Anadoluvius is found, demonstrates that great ape diversity in the Eastern Mediterranean is greater than previously believed, and that these hominids had diversified into multiple taxa long before their first documented appearance in Africa. So long story short, there's a new great ape that's been found called Anadoluvius, and it lived in what is now modern-day Turkey in this general area. Its characteristics unite it with Auranopithecus and Greco-Pithecus, other apes that lived in the area, and classifies them as hominines, also linking them with some more European northern apes. This suggests to the authors, and I think they make a decent case for it, that the very first hominines, so the first African apes, didn't actually evolve in Africa, but evolved outside of Africa and migrate back into Africa, where they formally begin to diversify into the lineages that are going to give us the hominins, the modern members of gorilla, and the modern panins. So to be clear, apes generally evolve in Africa. They leave Africa for Europe, those European apes diversify specifically out into Asia, where they become the members of Pangea, and then they also diversify into members of Hominidae, what would become the hominines there in Europe and in the Mediterranean area, before coming back into Africa and further diversifying into the lineages that would give us the modern African great apes. They're not considered the earliest African apes because they evolved in Africa, but because they are the ancestors, the last common ancestor of all modern African great apes. So gorillas, chimpanzees, bonobos, and of course, humans. And they have little canines. How weird! To really hammer home the relationship between these hominines and the hominins that would come later, including the aspects that kind of unite them morphologically speaking, meaning those small canines, some more work is going to need to be done. And indeed, more fossils are going to clarify this situation generally. But at present, it seems to be a really interesting situation. Anadoluvius is shaking things up. And wow, what a beautiful collection of fossils. So my gentle and of course very modern apes, I hope you enjoyed this. This was just a little search, a little literature search at some new findings. Some of you guys like the paper deep dive, some of you don't. And I wouldn't even classify this as a deep dive. We didn't get into any of their PCAs. We didn't touch their ANOVA. We didn't really do much with the tests that they did with regard to phylogenetics. We kind of just summarized the paper and I walked you through some of the potential implications. So maybe you liked it and maybe you didn't. But, you know, we have a diversity of content types on this channel. So if you like what I do, please consider supporting me in a free way. You can like, comment, and subscribe. And if you want to support me in other ways, you can join my Patreon or donate to my PayPal or buy stuff off my stores. And I hope to see you guys real soon next time.